Let us now move to the joins and subqueries exercises. The first exercise, retrieve the start times of members' bookings. Now, we can see that the information we need is spread out into tables because we want the start time for bookings, and that information is in the bookings table. But we want to filter to only get members named David Farrell, and the name of the member is contained in the members table. So because of that, we will need a join. So if we briefly look at the map for the order of SQL operations, we can see here that from and join are really the same step. And how this works is that in the from statement, sometimes all my data is in one table and then I just provide the name of that table. But sometimes I need to combine two or more different tables in order to get my data. And in that case, I would use the join. But everything in SQL works with tables, right? So when I take two or more tables and combine them together, at the end, all I get is just another table. And this is why from and join are actually the same component and they are the same step. So as usual, let us start with the from part, and we need to take the bookings table and we need to join it on the members table. And I can give an alias to each table to make my life easier. So I will call this book and I will call this mem. And then I need to specify the logical condition for joining this table. And the logical condition is that the mem ID column in the bookings table is really the same thing as the mem ID column in the members table. Concretely, you can imagine SQL going row by row in the bookings table and looking at the mem ID and then checking whether this mem ID is present in the members table. And if it's present, it combines the row, the current row from bookings with the matching row for members, does this with all the matching rows, and then drops rows which don't have a match. And we saw that in detail in the mental models course, so I'm not going to go in depth into it. Now that we have our table, which is comes from the join of members and bookings, we can properly filter it. And what we want is that the first name column is David in the column which comes from the members table, right? So mem.firstname is indicating the parent table and then the column name. And the surname is equal to Farrell. And remember, single quotes when using pieces of text. This is a where filter. You have two logical conditions, and then we use the operator AND because both of them need to be true. So now we have filtered our data, and finally we need to select the start times. And that's our query. Now remember that when we use join in a query, what's implied is that we are using inner join, and there are several types of join, but inner join is the most common, so it's the default one. And what inner join means is that it's going to return from the two tables that we're joining, is going to return only the rows that have a match, and all the rows that don't have a match are going to be dropped. So if there's a row in bookings and it has a mem ID that doesn't exist in the members table, that row will be dropped. And conversely, if there's a row in the members table and it has a mem ID that is not referenced in the bookings table, that row will also be dropped. And that's an inner join. Work out the start times of bookings for tennis courts. So we need to get the facilities that are actually tennis courts, and then for each of the facility we'll have several bookings, and we need to get the start time for those bookings, and it will be in a specific date. So we know that we need the data from these two tables because the name of the facility is here, but the data about the bookings is here. So I will go from cd facilities, join cd bookings on. what are the fields that we can join on logically. Now let me first give an alias to these tables. So I will call this fax, and this I will call book. And now what I need to see is that the facility ID matches on both sides. Now we can work on our filters. So first of all, I only want to look at tennis courts. And if you look at the result here, it means that in the name of the facility, we want to see tennis. And so we can filter on string patterns, on text patterns by using the like command. So I can take facilities name and get it like tennis, and the percentage signs are wildcards, which means that tennis could be preceded and followed by 0 or more characters. We don't care, we just want to get those strings that have tennis in them. But that's not enough as a condition. We also need the booking to have happened on a specific date. So I will put an AND here. So AND is the operator we need because we're providing two logical conditions and they both need to be true. So AND is what we need. And then I can take the start time from the bookings table and say that it should be equal to the date provided in the instructions, because I want the booking to have happened in this particular date. However, this will not work. So I can actually complete the query and show you that it will not work, because here we get 0 results. So can you figure out why this command here did not work? Now I'm going to write a few comments here, and this is how you write them, and they are just pieces of text. They're not actually executed as code, and I'll just use them to show you what's going on. So the value for start time looks like this. So this is a timestamp and it's showing a specific point in time. But the date that we are providing for the comparison looks like this. So as you can see, we have something that is less granular because we're not showing all of this data about hour, minute, and second. Now, in order to compare these two things which are different, SQL automatically fills in this date over here. And what it does is that since there's nothing there, it puts zeros in there. And now that it has made this extension, it's going to actually compare them. So when you look at this comparison over here between these two elements, this comparison is false because the hour is different. Now when we write this filter command over here, SQL is looking at every single start time and then comparing it with this value over here, which is the very first moment of that date. But there's no start time that is exactly like this one. So basically this is always false, and thus we get 0 rows in our result. So what is the solution to this? When we take a start time from the data, before comparing it, we can put it into the date function. And if I take my example here, if I put it into the date function, it's going to drop that extra information about hour, minute, and second, and it's only going to keep the information about the date. So once I do this, if I pass it to the date function before comparing it to my reference date, now this one is going to become the result, which is this one, and then I'm going to compare it with my reference date, and then this is going to be true. So all this to say that before we compare start time with our reference date, we need to reduce its granularity and we need to reduce it to its date. So if I run the query now, I will actually get my start times. And after this, I just need to add the name. And finally, I need to order by time. So I need to order by book start time. There is still a small error here, so sometimes you just have to look at what you get and what's expected. And if you notice here, we are returning data about the table tennis facility, but we're actually just interested in tennis court. So what are we missing here? The string filter is not precise enough, and we need to change this into tennis court. And now we get our results. Produce a list of all members who have recommended another member. Now, if we look at the members table, we have all this data about each member, and then we know if they were recommended by another member. And recommended by is the ID of the member who has recommended them. And because of this, the members table, like we said, has a relation to itself because one of its columns references its ID column. So let's see how to put this in practice. So to be clear, I simply want a list of members who appear to have recommended another member. So if I wanted just the IDs of these people, my task would be much simpler, right? I would go to the members table and then I could select recommended by, and then I will put a distinct in here to avoid repetitions. And what I would get here is the IDs of all members who have recommended another member. However, the problem does not want this because the problem wants the first name and surname of these people. So in order to get the first name and the surname of these people, I need to plug this ID back into the members table and get the data there. So for example, if I went to the members table and I selected everything where the mem ID is 11, then I would get the data for this first member. But now I need to do this for all members. So what I will have to do is to take the members table and join it to itself. And the first time I take the table, I'm looking at the members, quite simply. But the second time I take the members table, I'm looking at data about the recommenders of the members. So I will call this second instance Rex. So both of these, they come from the same table, but they're now two separate instances. And what is the logic to join these two tables? The members table has this recommended by field, and we take the ID from recommended by and we plug it back into the table, into memID, to get the data about the recommenders. And now we can go into the recommenders, which we got by plugging that ID, and get their first name and surname. I want to avoid repetition because a member may have been recommending multiple members, but I want to avoid repetition. So I will put a distinct to make sure that I don't get any repeated rows at the end. And then finally, I can order by surname and first name. And I get my result. So I encourage you to play with this and experiment a bit until it is clear. And in my mental models course, I go into depth into the self-join and do a visualization in Google Sheets that also makes it much clearer. Produce a list of all members along with their recommender. Now, if we look at the members table, we have a few columns and then we have the recommended by column. And sometimes we have the ID of another member who recommended this member. It can be repeated because the same member may have recommended multiple people. And then sometimes this is empty. And when this is empty, we have a null in here, which is the value that SQL uses to represent absence of data. Now, let us count the rows in members. So you might know that to count the rows of a table, we can do a simple aggregation, which is count star, and we get 31. And let's just make a note of this, that members has 31 rows, because in the result, we want a list of all members. So we must ensure that we return 31 rows in our results. Now I'm gonna delete this select. And as before, I want to go for each member and check the ID they have here in recommended by, and then plug this back into the table into memID so I can get the data about the recommender as well. And I can do that with a self join. So let me take members and join on itself. And the first time I will call it mems, and the second time I will call it recs. And the logic for joining is that in mems, recommended by is the same, is connected to recs memID. So this is taking the ID in the recommended by field and plugging it back into memID to get the data about the recommender. Now, what do I want from this? I want to get the first name of the member and the last name, surname, and then the first name and last name of the recommender. Surname. Great. So it's starting to look like the right result, but how many rows do we think we have here? And in order to count the rows, I can do select count star from, and then if I simply take this table, if I simply take this query and then close it in brackets, now this becomes a subquery. So I can, the subquery must have an alias, so I can give it an alias like this, and I get 22. So how this works is that first SQL will compute the content of the subquery, which is the table that we saw before, and then it will, we need to assign it an alias, otherwise it doesn't work. This changes a bit by system, but in Postgres you need to do this. So we call it simply T1, and then we run a count star on this table to get the number of rows. And we see that the result has 22 rows. And this is an issue because we saw before that members has 31 rows and that we want to return all of the members. Therefore, our result should also have 31 rows. So can you figure out why are we missing some rows here? Now the issue here is that we are using an inner join. So remember, when we don't specify the type of join, it's an inner join. And what does an inner join do? It keeps only rows that have matches. So we saw before that in members, sometimes this field is empty. It has a null value because, maybe the member wasn't recommended by anyone. Maybe they just applied themselves. And what happens when we use this in an inner join and it has a null value? The row for that member will be dropped because obviously it cannot have a match with memID because null cannot match with anything, with any ID. And so that row is dropped and we lose it. However, that's not what we want to do. Therefore, instead of an inner join, we need to use a left join here. The left join will look at the left table, so the table that is left of the join command, and it will make sure to keep all the rows in that table, even the rows that don't have a match. In the rows that don't have a match, it will not drop them, it will just put a null in the values that correspond to the right table. And if I run the count again, I will get 31. So now I'm keeping all the members and I have the number of rows that I need. So now I can get rid of all of these because I know I have the right amount of rows, and I can get my selection over here. And it would actually help if we could make this a bit more ordered and assign aliases to the columns. So I will follow the expected results here and call this mem first name, mem surname, rec first name, rec surname. Now we have the proper labels, and you can see here that we always have the name of the member, but some member weren't recommended by anyone, and therefore for the first and last name of the recommender we simply have null values, and this is what the left join does. The last step here is to order, and we want to order by the last name and the first name of each member. And we finally get our result. So typically you use inner joins, which is the default join, because you're only interested in the rows from both tables that actually have a match. But sometimes you want to keep all the data about one table, and then you would put that table on the left side and do a left join, as we did in this case. Produce a list of all members who have used a tennis court. Now, for this problem, we need to combine data from all our tables, because we need to look at the members, and we need to look at their bookings, and we need to check what's the name of the facility for their bookings. So as always, let us start with the from part, and let us start by joining together all of these tables. cd facilities on facility ID, and then I want to also join on members, and that is my join. So we can always join 2 or more tables. In this case, we're joining 3 tables, and how this works is that the first join creates a new table, and then this new table is joined with the next one over here, and this is how multiple joins are managed. Now I have my table, which is the join of all of these tables, and we're only interested in members who have used the tennis court. If a member has made no bookings, we're not interested in that member, and so it's okay to have a join and not a left join. And for each booking we want to see the name of the facility, and if there was a booking who didn't have the name of the facility, we wouldn't be interested in that booking anyway, and so this join here also can be an inner join and doesn't need to be a left join. This is how you can think about whether to have a join or a left join. Now we want the booking to include a tennis court, so we can filter on this table, and we will look at the name of the facility and make sure that it has tennis court in it with the like operator. And now that we have filtered, we can get the first name and the surname of the member, and we can get the facility name. So here we have a starting result. Now in the expected result, we have merged the first name and the surname into a single string, and in SQL you can do this with a concatenation operator, which is basically taking two strings and putting them together into one string. Now, if I do this here, I will get something like this. And so this looks a bit weird. And what I want to do here is to add an empty space in between and again concatenate it. And now the names will look fine. I also want to label this as member and this other column as facility to match the expected results. Next, I need to ensure that there is no duplicate data. So at the end of it all, I will want to have distinct in order to remove duplicate rows. And then I want to order the final result by member name and facility name. So order by member and then facility. And this will work because the order by coming second to last, coming at the end of our logical order of SQL operations. Over here, the order by is aware of the alias, is aware of the label that I have put on the columns. And here I get the results that I needed. Not a lot happening here, to be honest. It's just that we're joining 3 tables instead of 2, but it still works just like any other join. And then concatenating the strings, filtering according to the facility name, and then removing duplicate rows, and finally ordering. Produce a list of costly bookings. So we want to see all bookings that occurred in this particular day, and we want to see how much they cost the member, and we want to keep the bookings that cost more than $30. So clearly in this case we also need the information from all tables, because if you look at the expected results, we want the name of the member, which is in the members table, the name of the facility, which is in the facilities table, and the cost for which we will need the bookings table. So we need to start with a join of these 3 tables, and since we did it already in the last exercise, I have copied the code for that join. So if you want more detail on this, go and check the last exercise, as well as I have copied the code to get the first name of the member by concatenating strings and the name of the facility. Now we need to calculate the cost of each booking. So how does it work looking at our data? So we have here a list of bookings, and a booking is defined as a number of slots, and a slot is a 30-minute usage of that facility. And then we also have memID, which tells us whether the member is a guest or not. I mean, whether the person is a guest or a member. Because if MID is 0, then that person is a guest, otherwise that person is a member. And then I also know the facility that this person booked. And if I go and look at the facility, it has 2 different prices, right? One price is for members, the other price is for guests, and the price applies to the slots. So we have all of the ingredients that we need for the cost in our join, right? And to convince ourselves of that, let us actually select them here. So in booking, I can see facility ID, member ID, and then slots. And then in facility, I can see the member cost, the guest cost, and I guess that's all I need really to calculate the cost. And as you can see, after the join, I'm in a really good position because for each row, I do have all of these values placed on each row. So now I just have to figure out how to combine all of these values in order to get the cost. Now, the way that I can get the cost is that I can look at the number of slots, and then I need to multiply this by the right cost, which is either member cost or guest cost. And how do I know which of these to pick? It depends on the memID. If the memID is 0, then I will use the guest cost. Otherwise, I will use the member cost. So let me go back to my code here. And after this, I can say, I want to take the slots and I want to multiply it by either member cost or guest cost. Now, how can I put some logic in here that will choose either member cost or guest cost based on the ID of this person? What can I use in order to make this choice? Whenever I have such a choice to make, I need to use a case statement. So I can start with the case statement here, and I will already write the end of it so that I don't forget it. And then in the case statement, what do I need to check for? I need to check that the member ID is 0. In that case, I will use the guest cost. And in all other cases, I will use the member cost. So I'm taking slots and then I'm using this case when to decide by which column I'm going to multiply it. And this is actually my cost. Now let's take a look at this. And so I get this error that the column reference memID is ambiguous. So can you figure out why I got this error? What's happening is that I have joined multiple tables and the memID column appears twice now in my join. And so I cannot refer to it just by name because SQL doesn't know which column I want. So I have to reference the parent of the column every time I use it. So here I will say that it comes from the bookings table. And now I get my result. So if I see here, then I can see that I have successfully calculated my cost. And let's look at the first row. First, it's the mem ID is not 0, therefore it's a member. And here the member cost is 0, meaning that this facility is free for members. So regardless of the slots, the cost will be 0. And let's look at one who is a guest. So this one is clearly a guest, and they have taken one slot, and the member cost is 0, but so it's free for members, but it costs 5 per slot for guests, so the total cost is 5. So based on this sanity check, the cost looks good. Now I need to actually filter my table because we should consider only bookings that occurred in a certain day. So after creating my new table and joining, I can write a where filter to drop the rows that I don't need. And I can say, this is the time column that I'm interested in. The start time needs to be equal to this date over here. And we have seen before that this will not work because start time is a timestamp. It also shows hour, minute and seconds, whereas here is just a date. So this comparison will fail. And so before I do the comparison, I need to take this and reduce it to a date so that I'm comparing apples to apples on the time. Check that that didn't break anything. Now we should have significantly fewer rows. So now what we need to do is to only keep rows that have a cost which is higher than 30. So can I go here and say and cost bigger than 30? No, I cannot do it. Column cost does not exist, right? Typical mistake, but if you look at the logical order of SQL operations, first you have the sourcing of the data, then you have the where filter, and then all of the logic by which we calculate the cost happens here, and the label cost happens here as well. So we cannot filter on this column, on the column cost, because the where component has no idea about the column cost. So this will not work. But what we can do is to take all of the logic we've done until now and wrap it in round brackets, and then introduce a common table expression and call this T1. So I will say with T1 as, and then I can from T1, and now I can use my filter, right? So cost bigger than 30, I can select star from this table, and I'm starting to get somewhere because the cost has been successfully filtered. Now I have a lot of columns that I don't want in my final result that I use to help me reason about the cost. So I want to keep member, and I want to keep the facility, but I don't want to keep any of these. Great. Now, as a final step, I need to order by cost descending, and there's actually a issue that I have because I copy pasted code from the previous exercise. I kept a distinct, and you have to be very careful with this, especially if you copy paste code. Anyway, for learning, it would be best to write it always from scratch. But the distinct will remove rows that are duplicate and can actually cause an issue. Now I remove the distinct and I get the solution that I want. And if you look here, we have, if you look at the last two rows, you can see that they're absolutely identical. And so the distinct would remove them. But there are two bookings that happen to be just the same in our data. And we want to keep them, we don't want to delete them. So having distinct was a mistake in this case. To summarize what we did here, first we joined all the tables so we could have all the columns that we needed side by side. And then we filtered on the date, pretty straightforward. And then we took the first name and surname and concatenated them together, as well as the facility name. And then we computed the cost. And to compute the cost, we got the number of slots, and we used a case when to multiply this by either the guest cost or the member cost according to the member's ID. And at the end, we wrapped everything in a common table expression so that we could filter on this newly computed value of cost and keep only those bookings that had a cost higher than 30. Now I am aware that the question said not to use any subqueries. Technically I didn't because this is a common table expression, but if you look at the author solution, it is slightly different than ours. So here they did basically the same thing that we did to compute the cost, except that in the case when they inserted the whole expression, which is fine, works just the same. The difference is that in this case, they added a lot of logic in the where filter so that they could use a where filter in the first query. So clearly they didn't use any columns that were added at the stage of the select. They didn't use cost, for example, because like we said, that wouldn't be possible. So what they did is that they added the date filter over here. And then in this case, they added a logical expression. And in this logical expression, either one of these two needed to be true for us to keep the row. Either the memID is 0, meaning that it's a guest, and so the calculation based on guest cost ends up being bigger than 30. Or the memID is not 0, which means it's a member, and then this calculation based on the member cost ends up being bigger than 30. So this works. I personally think that there's quite some repetition of the cost calculation, both by putting it in the where filter and by putting it inside the case when. And so I think that the solution we have here is a bit cleaner because we're only calculating cost once in this case, and then we're simply referencing it thanks to the common table expression. So if you look at the mental models course, you will see that I warmly recommend not repeating logic in the code and using common table expressions as often as possible, because I think that they made the code clearer and simpler to understand. Produce a list of all members and their recommender without any joins. Now we have already solved this problem, and we have solved it with a self join. As you remember, we take the members table and join it on itself so that we can get this recommended by ID and plug it into members ID, and then see the names of both the member and their recommender side by side. But here we are challenged to do it without a join. So let us go to the members table and let us select the first name and the surname. Now we actually want to concatenate these two into a single string and call this member. Now, how can we get data about the recommender without a self join? Typically, when you have to combine data, you always have a choice between a join and a subquery, right? So what we can do is to have a subquery here, which looks at the recommended by ID from this table and goes back to the members table and gets the data that we need. So let's see how that would look. Let us give an alias to this table and call it mems. And now we need to go back to this table inside the subquery, and we can call it recs. And we want to select again the first name and surname like we're doing here. And how are we able to identify the right row inside this subquery? We can use a where filter, and we want the recs mem ID to be equal to the mems recommended by value. And once we get this value, we can call this recommender. And now we want to avoid duplicates. So after our outer select, we can say distinct, which will remove any duplicates from the result. And then we want to sort, I guess, by member and recommender. And here we get our result. So replacing a join with a subquery. So we go row by row in members, and then we take the recommended by ID, and then we query the members table again inside the subquery, and we use the where filter to plug in that recommended by and find the row where the mem ID is equal to it. And then getting first name and surname, we get the data about the recommender. And that's how we can do it. In the mental models course, we discuss the subqueries, and in this particular case, we talk about a correlated subquery. Why is this a correlated subquery? Because you can imagine that the query that is in here, it runs again for every row. Because for every row, I have a different value of recommended by, and I need to plug this value into the members table to get the data about the recommender. So this is a correlated subquery because it runs every time, and it is different for every row of the members table. Produce a list of costly bookings using a subquery. So this is the exact exercise that we did before. And as you will remember, we actually ignored the instructions a bit, and we did use not a subquery, but a common table expression. And by reference, this is the code that we used. And this code works with that exercise as well, and we get the result. So you can go back to that exercise to see the logic behind this code and why this works. And if we look at the author's solution, They are actually using a subquery instead of a common table expression. So they have an outer query, which is select member facility calls from, and then instead of the from, instead of telling the name of the table, they have all of this logic here in this subquery, which they call bookings. And finally, they add a filter and order. Now, this is technically correct, it works, but I'm not a fan of writing queries like this. I prefer writing them like this as a common table expression, and I explain this in detail in my mental models course. The reason I prefer this is because it doesn't break queries apart. So in my case, this is one query and this is another query, and it's pretty easy and simple to read. However, in this case, you will start reading this query and then it is broken in two by another query. And when people do this, sometimes they go even further, and here when you have the from, instead of a table you have yet another subquery. It gets really complicated. So because of these two approaches are equivalent, I definitely recommend going for a common table expression every time and avoiding subqueries unless they are really compact and you can fit them in one row.